Okay, we're going to take a look at solving literal equations. I already did a video on this, but these problems are a little harder. They're going to require you to collect like terms. Okay? And that's going to be a little trickier to collect like terms of the variable you're solving for. At this time, you really need to have done the flashcards I've provided on the Moodle on um, collecting like terms for literals. Okay? Also, you should have seen the video I did for solving simple literal equations. We're going to loosely apply the five-step method here, which is distribute, collect like terms, get all your letters you're solving for on one side, undo, add, subtract the inverse, undo, multiply, divide with the inverse. You need to be comfortable with those ideas before we start trying to apply them to these harder problems. Okay, so look what the directions say. They say, please solve the following equations for the indicated variable. And in this first equation that says ax plus bx minus f equals 2f, we will be solving for x. So if you notice here, we've got two terms of x. That'll probably require us to collect like terms at some point. So let's see. Is there any distribution needed? No. Do we need to collect like terms? Yes. We're going to collect ax plus bx. That is going to give us the quantity of a plus b x, bringing down the rest of the problem, minus f equals 2f. Now, we're going to look to get all our letters on one side that we're solving for. A lot of letters, but the only one we're solving for is x. So we're good there. Now we're going to look to undo, add and subtract, and multiply and divide using the inverse. We'll have this minus f, so I'm going to plus f to both sides. Excuse me, add f to both sides. It cancels on the left, bringing down the problem that's unaffected. It's a plus b times x equals 3f. Don't forget you can combine like terms when the letters are the same. Okay, now we're going to look to undo multiplication and division. Although it says addition in the quantity here, that's not the operation you're undoing. The operation you're undoing is right here. It's that multiplication. So I'm going to multiply, excuse me, I'm going to divide, because I am multiplying in the problem. I'm going to undo it with division by the quantity a plus b. Okay, that'll cancel here, leaving me with x equals 3f over a plus b. There's one little more thing you need to do here too to really get the problem in terms of understanding it. This part here, the denominator, cannot be equal to 0. Excuse me for that little, well, again, it cannot be equal to 0. Okay? A little slip of the tool there a second ago. I was trying to write a 0. The magic pen kicked in. So what we need to do here is say that A cannot be equal to the opposite of B. So if we're saying if these two numbers are opposites, they're going to make 0 when you add them together. So that's called a restriction. Okay, that's the appropriate way to state the answer to this problem. Although I will give you over here is a little bit more of the important part. Okay. Now let's continue on and look at the next problem where we have h equals gd minus m minus bd plus cd. And we're solving for d. If we notice here, we've actually got three terms that have d with them. And one time it's a minus, and one time it's a plus. So we need to be extra careful when we do the collection of like terms there. Okay? So let's see. Is there anything to distribute? No. So I'm going to collect like terms now. I'm going to get gd minus bd plus cd, which is going to give me the quantity of g minus b plus c times d. I'm going to pull down the m that's in subtraction that has not been affected by that collection. So h plus m by adding m to both sides to undo my addition and subtraction times is equal to the quantity G minus B plus C times D. Now again, although you're seeing more additions and subtractions here, that's not what I'm trying to undo. I'm going to try and undo this multiplication. So I'm actually going to divide by this big quantity of G minus B plus C. Okay? And I'm going to do that on both sides. G minus B plus C. Sometimes referred to as the golden rule of algebra. Whatever you do on one side, you do the other. So that's going to be D equals quantity H plus M divided by quantity G minus B plus C. Now, that's pretty much the answer, but we're going to do the restriction. And I guess if you logic it out, if G plus C were equal to B, when you subtract the B, you'd get 0. So, just quickly, G plus C cannot be equal to B. Because if you add G and C together, it's the same as B. When you subtract B, you get 0. So, that is the answer here. And again, the one thing you want to notice is how we collected like terms in each of these problems. And if you want to take a look, the video will stop here in a second. And you might want to take a look at how I went from first line to second line in both problems.